What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. I recently made a video on solving radical equations, and I think it's a pretty good introduction with some good examples to practice. But one thing I didn't get to on that video is examples like this, where we have a radical equation with two radicals. So that's going to be the focus of this video. We're going to do two examples of equations like this with two radicals in them. Hopefully this helps, just in case this comes up on a homework, quiz, or exam. But again, if you're still not fully feeling comfortable with radical equations in general, go watch that other video first and then come back to this. This is going to be a little bit more involved. So remember, how did we approach solving radical equations? In that last video I said our goal, the first thing we want to do is isolate the radical. So in this case, we don't just have a radical, right? We have two radicals. So which one do we want to isolate? Well, really the answer is whichever one we want. This example makes it easy for us because one of them is already isolated, right? It's already by itself. Again, that's what I mean by isolated. I mean, I want radical equals stuff, right? I want that radical by itself on one side of the equation. So since we already have that for us, then we can just have this one isolated. And now what we do is square both sides of the equation. Because again, that's the whole reason we isolate the radical, is so we can get rid of it by squaring both sides. And again, if this were a cube root, we would cube both sides. If it were a fourth root, we would raise both sides to the fourth power. It's always to the index of the radical, okay? So if we square both sides of the equation, we're gonna get rid of that square root. On the left-hand side, we're just gonna have 3x plus 1. And now what do we have on the right-hand side? Well, remember, squared means times itself. So here's what I like to do, and I especially recommend this if you're still getting comfortable with solving these equations, is write this out. 1 plus square root of x plus 4 times itself. 1 plus square root of x plus 4. Because now what we can do is use that four-letter F word that everyone learns about, FOIL, and we can multiply this out. 1 times 1 gives us 1, plus 1 times the square root of x plus 4 gives us square root of x plus 4, plus square root of x plus 4 times 1 gives us square root of x plus 4 again, plus square root of x plus 4 times itself. Remember, times itself means squared. So square root of x plus 4 squared, that square root and square are going to cancel, and we're just going to be left with x plus 4. You can write it out if you want to, if you need help seeing it, but the square root times itself, that means squared, those are going to cancel. We're going to be left with x plus 4 here. So now what we have is a couple of like terms that we can actually combine. This is a little bit tricky. It's always hard to see at first, right? Well, let me show you what I mean. Let me start copying this down first. I'll just leave the left-hand side alone for now. Square root of x plus 4 plus square root of x plus 4 is 2 times the square root of x plus 4, right? Remember, multiplication is repeated addition. 2 times something is that something plus itself, right? If this were x plus x, we'd combine it to be 2x. Just think of it as a fancy x. It's a little bit tough to see, but this is going to come up in a lot of these examples where you're going to be combining like terms with radicals like this, okay? Then off here we have plus x plus 4. We really don't need these parentheses. I'm just in the habit of using parentheses like that whenever we cancel a square root and a square. Sometimes it matters. In this case it didn't. All right, now what we have is an equation with one radical in it. If you watched that last video and you're comfortable solving radical equations with one radical, you should be good from here, right? So that's the process. When we have two radicals, we isolate one of them. We raise both sides to whatever power we need to get rid of that radical. Once we get rid of that and combine like terms, we have one left. From here on out, the process is the same as it would be solving a radical equation with one radical. So the more radicals we add, it just means we add these more steps that we repeat. Isolate a radical, get rid of it by raising both sides to a power. Isolate another radical, get rid of it by raising both sides to a power, and just repeat that until all the radicals are gone. Right? We're not going to do an example with 3. We'll stick with 2. But let's see if we can continue this. Okay, so now we have this equation we can solve. So I can start doing some stuff. So let's see, I'll use a different marker because what I'm going to do is combine 1 and 4 to be 5. Okay, so combine 1 and 4 to be 5. I want to write out every step. So we have 2 times square root of x plus 4 plus x plus 5. So I combine those two like terms. Now what I can do is subtract. Now I'm going to do two steps at once. I think y'all can follow this though. Minus x and minus 5. Two steps at once. Minus x minus 5. What that's going to do is get rid of this plus x, obviously, as well as this plus 5. So what we're going to have on the right-hand side is 2 times square root of x plus 4. On this left-hand side, we have 3x minus x, that is 2x. I'll use the blue marker for continuity here. 2x. And then we have 1 minus 5, so that's minus 4. And that equals 2 times the square root of x plus 4. Now to isolate this radical, we can divide both sides by 2. Divide by 2. Divide everything by 2 on the left-hand side, right? So this 2 and 2 is going to cancel. So I'll write the next step over here. Let's do that with black. Draw that arrow. 2 and 2 cancels. So what happens here? These 2's cancel as well. So what is our left-hand side of the equation? Those 2's cancel, so we have an x minus 4 over 2, which is 2, right? So this simplifies to x minus 2, which equals, these 2's canceled, so now we have square root of x plus 4. So now, what do? Well, we have the last radical that's left, isolated. So now what we can do is square both sides, right? The square and the square root are going to cancel out, so this right-hand side is just going to be x plus 4. And on this left-hand side, we can write it out twice if we want to, and use that 4-letter F word again. X minus 2 times itself, right? And on the right-hand side, we just have x plus 4. So let's draw an arrow here. X times x, that is x squared. X times negative 2, that is minus 2x. And then we're going to have minus 2x, minus 2 times x, that's another minus 2x. Those are going to combine to be minus 4x. Hopefully y'all see that. I did 2 steps at once. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. So those two negative 2x's combine to be this negative 4x. And then negative 2 times negative 2 is positive 4. So plus 4. And that's equal to x plus 4. Now we can do some nice canceling here. Because now we have a quadratic, we want to get 0 on one side, everything else on the other side, see if we can factor this thing and solve it. That's my approach. That's the approach I typically take. So we can actually subtract x and subtract 4 from both sides. When we subtract 4, we get rid of the constants altogether. When we subtract x, the right-hand side, we have 0. We got rid of everything on the right-hand side. On the left-hand side, we have x squared still. We haven't messed with that at all, so we still have x squared. And what do we have? Minus 4x minus x. That is minus 5x. And that is equal to 0. This can be nicely factored. Let's draw an arrow here. We can take out an x. There's a common factor of x, and what we're left with is x minus 5. And this equals 0, which means that x equals 0 or x minus 5 equals 0. That gives us two potential solutions. X equals 0 or x equals 5, right? And remember, when we're solving these radical equations, we always have to check our solutions at the end. So let's go back and plug this in. Let's try 0. What happens in this original equation? 3 times 0 is 0 plus 1. So we get 1 on the left-hand side. So maybe I should keep track of this. So let's check x minus 0. What do we get? On the left-hand side, we get 3 times 0, that is 0, plus 1, that is 1. The square root of 1 is 1. So we get 1 equals 1 plus 0 plus 4, which is 4. Square root of 4 is 2. So we get 1 equals 3, which is nonsense, right? So 0 does not work in the original equation. It does not satisfy the original equation, so that's no good. So let's see if 5 works. Let's check x equals 5, okay? So on the left-hand side, we get 3 times 5, that's 15, plus 1, that's 16. The square root of 16 is 4. So we get 4 equals 1 plus, so again, we're testing 5. So 5 plus 4 is 9, square root of 9 is 3. So we get 4 equals 4. So 5 is a solution. So the only solution to that original equation is 5. 0 was an extraneous solution. So our final solution set is the set containing 5. So these examples are a little bit long, so this is going to be the last one for this video, but what I encourage you to do right now is pause the video, pull out a pencil and paper, and see if you can work this out on your own. Then press play to check your answer. Alright, so I'm going to assume everyone has a perfect solution on their own and you're just checking your answer. So hopefully the first thing you did was isolated a radical. And I'm guessing the radical you chose was probably this one, because all we have to do to get this one by itself is add the square root of 3x plus 1 to both sides, right? If we do that, if we add the square root of 3x plus 1 to both sides, then what happens is these cancel here. On the left-hand side, we have the square root of x minus 1. And on the right-hand side, we have negative 2 plus the square root of 3x plus 1. And so we have exactly what we want, which is one of the radicals isolated. And now we can square both sides, right? So now we're squaring both sides, because doing that is going to get rid of the radical on the left-hand side of the equation. We're just going to be left with x minus 1. And on the right-hand side, again, what I'm going to do is let's just write this out twice. That way we don't make any silly mistakes from trying to do it all in our head, right? Because square is multiplied by itself. We can write it out twice, and we can use that 4-letter F word that you probably all know, FOIL. So we're going to start with the first, negative 2 times negative 2. That's going to give us 4. And then I have minus 2 times the square root of 3x plus 1. So that's minus 2 times the square root of 3x plus 1. And then we have square root of 3x plus 1 times negative 2. So once you start practicing this and getting really good at this, you're going to start combining these like terms in your head in one step. You're just going to be able to say, okay, I know that's going to happen, and I know that's going to happen, and I'm going to write negative 4 times the square root of 3x plus 1, right? But that comes once you get a lot of experience, a lot of practice with doing this. This last step, same as the last example, square root of 3x plus 1 times square root of 3x plus 1. That's the square root of 3x plus 1 times itself, or squared, right? So the square root and the square cancel, and we're just left with whatever's on the inside, which in this case is 3x plus 1. So again, minus 2 times the square root of 3x plus 1, minus 2 times the square root of 3x plus 1. Those are going to combine to be minus 4 times the square root of 3x plus 1. So let's go ahead and do that. X minus 1 on the left-hand side. 4 minus 4 times the square root of 3x plus 1 plus 3x plus 1. Okay, so this is where we're at now. So again, we have one radical now. So now we just have a radical equation. So our goal is combine some like terms, see if we can isolate this radical term here. Then we're going to square both sides, and from there solve that resulting equation and check our answers, right? It's not bad from here on out, just maybe a little bit tedious. So 4 and 1 we can combine. I'll circle those. 4 and 1. We can combine those to be 5. So let's go ahead and start by just doing that. So left-hand side we left alone. That is x minus 1. The right-hand side we combine 4 and 1 to be 5. So let's write that off at the end. We have negative 4 times the square root of 3x plus 1 plus 3x. We left that 3x alone, right? So all we did was combine the 4 and the 1 to be plus 5. So now what we can do, we can isolate this radical term by subtracting 3x from both sides, minus 3x, and subtracting 5 from both sides, minus 5, minus 5. So on the right-hand side, this is all going to cancel. We're just going to be left with that radical term on the right-hand side, exactly how we want it. On the left-hand side, we have x minus 3x, that is negative 2x, and then we have negative 1 minus 5, that is negative 6, which equals negative 4 times the square root of 3x plus 1. So here's where it's a little bit tricky. I'll admit this is a little bit tricky because typically what we want to do is isolate this radical. So we would divide both sides by negative 4, which you technically can do. But what it's gonna do is it's gonna make your life a little bit harder, because what happens when you do that is that you're gonna end up with fractions over here. Specifically, this term is gonna be a fraction. And remember, the next step after this is gonna be to square both sides. I don't really wanna be squaring terms with fractions and having to FOIL out stuff like that. I don't really wanna do that. So instead of dividing both sides by -4, I'm gonna divide both sides by -2, because I'm still gonna be able to simplify and cancel some stuff on the left-hand side, but I'm not gonna be left with any fractions. So hopefully it makes sense why we do that. Divide both sides by -2. Again, either way works. I'm just trying to work smarter, not harder, if that makes sense, okay? So let's think about what happens when we do this. We divide everything by -2. So the -2 over -2 cancels. On the left-hand side, we are left with x. The negative and negative cancel. 6 over 2 is 3. So x plus 3 on the left-hand side, right? On the right-hand side, -4 divided by -2, that gives us 2 times the square root of 3x plus 1, okay? So now what I can do is square both sides. Square both sides. And that 2, it's not really going to mess me up at all, because I have 2 squared is 4. This squared, I just get rid of the square root, right? And another thing you can actually do is break this up. Let's actually go ahead and do that. So we know that x plus 3 squared is x plus 3 times itself. I hope I have room to do this here. So x plus 3 times itself. So we're going to end up multiplying that out using that 4-letter F word. And on the right-hand side, whenever we have things being multiplied in here and they're being squared, remember our exponent rules. If we have, 2 things being multiplied and it's squared, that's the same thing as a squared times b squared. So we can sort of distribute that squared, and what we're going to get is 2 squared, which is 4, times square root of 3x plus 1 squared, right? And those are going to cancel, so we're just going to be left with 3x plus 1. And now we're getting to be in pretty good shape. This is going to become, we're going to have an x squared term, we're going to end up with a quadratic, we're going to get 0 on one side, solve, check our answers, right? Pretty routine from here on out. So let's see what we can do. X times x is x squared. I'm going to skip a step here because we have x times 3, that's 3x, plus 3 times x, that's 3x. Those are going to combine to be plus 6x, and then we have 3 times 3 is 9. So that's what I'm talking about. As you get more experience, you'll be able to notice stuff like that and do stuff like that in your head instead of writing out plus 3x plus 3x. The right-hand side we can distribute. We have 12x, right? 4 times 3x, that's 12x, and then 4 times 1, that's 4. So now let's see. I'm going to get rid of this eraser. Let's see if we have room to finish this problem. I'm going to get 0 on the right-hand side, and I could do that by subtracting 12x from both sides and subtracting 4 from both sides. So again, doing 2 steps at once because I'm running out of room. So this right-hand side, everything is going to cancel. I'm going to be left with 0. So let's see what we have on the left-hand side. X squared, that was left alone. 6x minus 12x. That is minus 6x. 9 minus 4, that is plus 5, and that equals 0, okay? So now I think this is factorable. Let's see if we can factor this. Hopefully it is, because I definitely do not have room for the quadratic formula. I think it is. 2 numbers that multiply together to be 5 and add together to be -6. I think that's going to be x minus 1 times x minus 5 equals 0, okay? And we can check that by multiplying this out. We get x squared minus 5x minus x, that gives us that minus 6x, and then -1 times -5 gives us that plus 5. So this is definitely the correct way to factor this, and that gives us 2 potential solutions, which are, I'll write them up here. Potential solution, x equals 1, as well as x equals 5. And what I'm going to go ahead and say is that both of these solutions work, and that I will leave as an exercise for you to go back and plug both of these in and confirm that they in fact do work. So hopefully this helps. If something like this comes up on your homework or a quiz or exam, or maybe you just found it fun to challenge yourself a little bit and try a problem that you've never tried before, if you enjoyed the video, make sure to like and subscribe. Leave a comment if you have any questions or feedback, but most importantly, keep flexing those brain muscles, and I'll see y'all later.